do a couple quick examples of these free body diagrams on this simulation, just to make sure you understand what's going on. So let's take a look here. What we have is the cabin of a small freight elevator is secured to a motor by a cable, is moving upward with a constant speed. There is no contact between the cabin and the elevator shaft, and ignore air resistance. So a couple things we want to look for here. First of all, when you see something that says constant speed is really important to think about because that means equilibrium, which means all the forces are going to be balanced out. So whatever happens down here in this free body diagram, we have to have balanced forces. So we have a cable and constant speed, and there's no friction and there's no air resistance. That's what it means there's no contact between the cabin and elevator shaft, as there's no friction. So we're always going to have gravity going down here. So let's choose gravity going down. And we have to have something to balance that gravity going up because it's moving at a constant speed. So what is attached to the elevator is a cable, and a cable means we're going to have tension. So we have tension going up. Notice how I could, if I wanted to, click on tension and make it bigger, or click on gravity and make it bigger. I can make them both bigger. What I want to make sure is that I have it balanced because it's moving at a constant speed. So everything is balanced. It looks pretty good. Nothing's happening to the left and the right. No air resistance. This should be good. Okay, great. Got it. Let's try this one. A rightward, this is going to be good. This is tricky. A rightward moving car is skidding to a stop across a level roadway with locked wheels. Ignore air resistance. Okay, so what this means is we have a not equilibrium situation because it's skidding to a stop. That means acceleration, right? I know it's slowing down, but we still say acceleration even though something's slowing down. So if it's skidding to a stop across a level roadway, that means it's moving to the right, but there's a force pushing it to the left, right? A net force pushing it to the left. How do I know it's to the left? Because it's slowing down. Its acceleration is in the leftward direction. So it's moving to the right. Velocity is in the right direction, but acceleration is in the left direction. So we have to make sure we have a net force in the left direction. So let's start with gravity as we always have. Down, gravity, good. There has to be something in the upward direction to balance out the gravity. And when you have an object that's on a surface, we're going to have a normal force. So that's going to be normal force up. We want to make sure that those two are balanced. We want to have something pointing to the left here. So left. And all my choices, it's not gravity, it's not normal, it's not a spring, it's not an applied force, it's friction. Friction is slowing it down. It's skidding to a stop. Now it actually doesn't matter whether I have this one longer or shorter. It's going to give me the right answer as long as these two are balanced. So I could have both of these long or I could have both of them short. And if they're balanced, then I should get it. Okay, good. So let's just think about this one. I'm going to describe it to you, and then I'm going to let you do it on your own. So a sledder has reached the bottom of a hill and is coasting to the right while slowing down along loosely packed snow. So moving to the right and slowing down. So that's the same thing. We're going to have a net force to the left direction. We're going to have a gravity force, we're going to have a normal force, we're going to have a friction force, and we're not going to have air resistance. This is going to be really similar to the last one. So let's just check answer, and we got it wrong. Okay, got it. Check answer. Can I do another one? Let's just click on a different one over here. I don't know. How do I get to a different one? Can't do it. Okay. Well, anyway, this is for you to do. Hopefully that was helpful just to get you started. Just keep trying them and keep trying them, and eventually you will get it. This is kind of like learn by doing here, and making mistakes is also okay. Okay. See you in class.